Welcome back to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Manegra, and today we're going to look at the p-value. What exactly is the p-value? So we're going to see the p-value with inferential statistics. Anytime we're using inferential statistics, we will get a p-value at the end. So what does this mean? Now, remember, descriptive statistics are the summaries of data using percentages, ratios, or raw numbers. So if I say 75% of the participants responded in this particular manner, or 30 out of 50 of the participants responded in this particular manner, I'm just giving raw numbers or percentages or ratios. I'm not telling you if it is statistically significant. So these are just descriptive statistics. Inferential statistics, on the other hand, allows you to make predictions or inferences about the population based on the sample. So at the end of this, I will get a p-value. And you can see here in an independent samples t-test, I've got a p-value at the end of this table of 0.005. This chi-square is less than 0.001, and this ANOVA is 0.009. So what does this mean? How can I tell if my test worked based on this particular number? So the p-value refers to the probability, and probability allows us to quantify chance. So it's used when we're interested in the likelihood that an event will happen. And of course, an event is an outcome or set of outcomes in an experiment. So if the probability is 0.5, it just means that it's just as likely to happen as it would not happen. So there's a 50-50 chance that something could be true. And of course, 50-50 is not what we're looking for in our studies. We want to know that it's not happening by chance. So we use inferential statistics to make predictions. And the key to probability is making predictions, and this is the underlying goal. We also have the law of large numbers. So if I were looking at the probability of rolling a combination of numbers with a set of dice, the more often we roll the dice, the more likely the results will be closer to the results we would expect based on theoretical probabilities. Now, this is also true with the sample size. The larger the sample size, the more likely the results will be closer to the results we would expect based on theoretical probabilities. So that again is why your sample size matters. Okay, so I don't have exactly where I got this meme from, but a p-value of 0.6 is a very scary thing to many researchers because what we're looking for is a p-value less than 0.05. If the p-value is less than 0.05, we reject the null hypothesis in favor of the alternative hypothesis. So if the p-value is less than 0.05, we have the results we were looking for. So we made a hypothesis or prediction at the beginning of our study or at the end of the background information of our thesis. We have it laid out there. And if we get a number less than 0.05, then we can accept our alternative hypothesis and reject the null hypothesis. This is what we were hoping to find. However, if the p-value is greater than 0.05, we reject the alternative hypothesis in favor of the null hypothesis. So in this case, we didn't get the results that we were looking for, and that just means that we have to readjust and retest. You still want to report the data and the numbers properly. So in the case that we don't get the numbers that we look for, we have to come up with a potential solution as to why that could have been, or the limitations in the study that could have prevented us from getting the number that we were looking for. So if the p-value is less than 0.05, we don't have the results we look for, and we look for alternative explanations as to why that is. So this shows us here with the data set, this is for a Z test showing the Z scores, and we have a high and a low end. So we've got negative Z numbers and positive Z numbers. If you notice, this is a two-tailed test, and we can have a p-value of 0.05 on either end. So the p-value, and the closer it is to 0.001, the less likely that the results are random. So this is what we're looking for, a p-value less than 0.05 and the closer to 0.001. We know that this isn't random. We know that we have the results that we're looking for, or maybe we don't have the results that we're looking for, but then this tells us whether or not the testing that we did based on our hypothesis worked. So this comes to the end of this video. Thank you so much for watching, and I look forward to seeing you in the next video.